Hi, thank you very much, everybody. So I'm very happy to be here in Taiwan for my first time. So really, thank you very much to have been invited. So today we are going to talk about functional programming and Kotlin, which are two things that I like, quite enthusiastic. I like to talk about. How many of you have used Kotlin? I mean, do you know Kotlin? Okay, not so much. So this talk will be mostly live coding. So, okay, anyway, the code is on GitHub, so you can look at later. I would say let's go slow, but there is not much time. So, but if you don't understand, please stop me. It's important that you understand. And how many of you have some experience or know about the functional programming? Okay, that's good, perfect. So let's start a bit. Okay, this is my book. It took me a few years to write, and it's not just about functional programming, but how to do, a real day-to-day work. So best practice, how to set up a test. The whole object craftsmanship, if we want. So it's not specifically about, and doing a whole application, not just doing a small thing. So it's a bit heavy. The original idea was to do like 250 pages. It is almost 400. So it was a bit of failure in that sense. But this is my book, so you are free to buy it if you want. But I have a copy here, so if you tweet something about this talk, then we can have a raffle at the end, and I will. I want to bring this back in the airplane. So, and so let's progress. Since during the COVID, I moved to Japan. And one thing that is interesting about Japan is that I had this idea of Japan to be super technological things. But there is a lot of not misunderstanding, but preconcepts that are actually not very true about Japan. One is that Japan is super technological. But when you start working in Japan, and you go to the bank in Japan, it seems to be back like 50 years. Everything must be done manually, filling forms. And then they ask you, okay, what is your fax number? My fax number? Come on. My daughter never doesn't know what is a fax. I mean, come on. Anyway. So, this misconception is not only about Japan. Similar misconception, like something that is modern, but it's not that modern, it's also true for functional programming. And functional programming seems a super new thing, but actually it's starting from 60s. And only now is getting, for a lot of reasons, I mean, partly hype, but also for computer or advanced. So a lot of reasons make a very good choice now, but it's not something new. And, functional programming is mostly about function. The name is a bit of a giveaway. And, but they are function in a kind of a mathematical sense, not function as we are using in, not exactly function as we are using programming. So the idea of a mathematical function is, it's a transformation. It's a bit like when the water became coffee. So there is an input, there is an output, and something in the middle change. So this is the idea of functional programming. And if you do this, and use a transformation. That's you are doing functional programming, and forget about all this complicated stuff that they told you about. It's not. But the second rule is that functional transformation, but it's also important that the functions are transparent. And what I mean with transparent, I mean that they cannot have cats. No, not cats. But they cannot have something hidden. They cannot have a hidden input and output. Everything must be explicit. So everything that a function use must be either in its argument or in its return type. And if you are able to do this, you are doing functional programming. Because the point is that functions that are transparent and just pure transformation can be combined together. If a function have a hidden input and output, they cannot safely be combined together. I mean, maybe yes, maybe not, but you have to check case by case. If everything is transparent, you can just combine and be safe and sure. And this is particularly true for database. And today we will very quickly look at 3 possible strategies how we can keep everything transparent and explicit using a database. So the first one is about partial application. So we will see how to partially apply a function. The second one is familiarly called the reader monad, but nothing difficult. Just and the third one is usually called algebraic effects, but in Kotlin it will be using context. What is it called? Context receiver. But yeah, we will see some code. But so basically, this whole point is just to show that functional programming is not rocket science. It's something very simple, something that you can use, and something that actually brings you some advantage right now without using complex language or library or have to study category theory or other stuff. And so, of course, there is a lot of other things, but to start, it's very simple. And this is particularly true for web application. Because a web application is just an application where you have a web server is something that take an HTTP request and send an HTTP response. So it's just a transformation. So the whole web server at the end, it just works as a single function that with an input and an output. And that makes functional programming really, really good, in my opinion, to work with web application. If for other kind of application, like video games or desktop application, it could be maybe object-oriented is better solution. Maybe yes, maybe not, I don't know. It's another talk. But for web application, I think that functional programming is really great. So let's further ado, let's go to live coding. Yeah, how can we do? Let's see. Can you hear me? Yeah. So, yeah, well, for me it's okay. Sorry for you. So, okay, you cannot see my screen. Sorry. Okay. You can see, I suppose. Okay, this is a very simple application. Everything is on GitHub, so don't worry. I'll give you everything later. And this is, but just it's even simpler if we just started. So it's you know, super sophisticated application that you can write a name and email and add the user. And then can go to see user detail and go back. So this is you know, very sophisticated web application. But the point, of course, is that for a talker, the application must be very simple. But even for a complex application, it's more or less the same structure, basically. I want to concentrate on things. And in this case, I'm using this HTTP4K library. That is a great library to write a web application. Because basically, you can define your application as in this very simple. You put the root, and you say the method get, and then you call this function. And this function is just a function that takes a request and that put a response. So this is how you define your application. Then you say application as a server, start, and that's it. Okay, so this is the application. And is everything clear up till now? No confusion. Yeah, I mean, if someone thinks that I'm missing something, which is absolutely possible, almost probably it will happen, just, I mean, raise your hand or stop me if I'm skipping some steps and stuff like that. But as we said, that we want everything to be explicit. But if we look at one of these functions, you can see that, okay, it gets a request and return a response. So far, so good. But it loads all the user, for example. But how can it load all the user from a request? Of course, it has a hidden dependency on database. And what we want on a functional program is to avoid this kind of hidden dependency. Everything must be explicit. So if you use a database, you need to declare to pass it explicit. So the first thing that we are going to do, oh, by the way, for the database, I'm using JetBrains exposed library, which is a kind of a nice library to write a database. It's a bit too object-oriented for my taste, but it's okay. You can use. But I wanted to use it in an explicit way. I mean, here what's happened is that behind the scene there is a singleton. So you have a function that is called a save user that has a dependency on a singleton with a database transaction. And that is a problem if you, for example, don't realize that and you are using some word very quickly or stuff like that, and the transaction is not open or stuff like that. So this is the kind of stuff that we don't want. So first thing first, basically what I want to do is make the database an explicit parameter. And pass the database to the transaction. So in this case, basically this became an explicit. And I can do, yeah, in every place. Now, let me go back a second. first we need a database. So PrepareDB is returning a data. PrepareDB basically is just create the schema if it's not, and delete any user from. Of course, delete every user is only for demo. You don't do that in production, but we wanted to pass it explicitly. And probably want a database to be put in this user service. And then be passed around, something like that. Now, because of time constraint, I cannot do everything slowly live coding because it really will take more than 1 hour. And so let's skip quickly to another branch where basically this is the first step. But the problem is that okay, this is a kind of a cache. But the problem that I wanted to show here is that this class user service is where basically, in this case, it's very simple, but in a real application where you put all your logic. And here, all your logic will basically be attached to a database. So it will be something that it will be impure, something that to test, you need a database and stuff like that. What we want is a way to separate the part that need our logic to be completely pure and functional, and the part that database will be connected later, basically, from the external. So the kind of trick with functional programming is putting all the impure, non-transparent dependency on the border of the system, and try to have as much as code as possible completely pure. Because the pure code we can combine as we want, easy to test, easy to write, and clear. And the infrastructure code we keep at the border. But so let me skip to the branch because really there is not much time to actually let's maybe I should have just but anyway. Okay, so partial application, let's see. Now, if we go back to partial application, we see that it's an example of using hexagonal. You are familiar with hexagonal port adapter architecture? Probably not much, but anyway, it's a kind of a pattern that is used mostly in object-oriented, but actually works also very well with functional programming. And the idea is this one. I get this function that, this is the Kotlin way to declare a function type. So load user is a function that take a user ID, return a user, optional user. Save will take a name and email and return a user ID. And this take anything, but they will return the list of all users. So in this case, our user function, user service will take 3 functions, and we'll use it. The code inside is the same than before. But what's not the same is how the main is. So we created this class that basically split to read a database. To read the user, we need a database and the user ID, basically. So we create a class that implement a function. So this is something that is quite common actually in Kotlin and Scala. But it's a bit of a surprise for a Java user. So instead of declaring an interface, we basically implement a function. So this class, so the instance of this class, it's also an instance of this function. So we can pass an instance of this class where the function is required. And because this class has also some optional parameter at the beginning, not optional, additional parameter at the beginning, basically we are splitting, we are doing a partial application of the function. First, one parameter when we create, and then the other parameter when we actually call the function. We can do it also directly with the function, but this is quite nice. And so what we have basically is that our user service is taking this function that have the database inside. But the good thing about this approach is that the user service doesn't have anything about the database. You see, here there is no dependency on database. So we can test the user service just passing three functions that return a user. I mean, it can be just onPlace, Lambda, or stuff like that. Very quickly, and we can verify all the logic if there are, all the kind of logic that is in our domain. And everything here will be completely pure, completely functional. Instead, this thing is not functional. Well, it's explicit, but of course there is a call to database. So it's not bad, but it's not. But this can be tested separately. So if you know that this is working, then you could put, and most of your code is functionally pure. Okay, so this is a solution, which is great if you wanted to have something simple, because it's relatively simple to use this partial application. And also, when writing functional programming, is quite common to have this kind of dependency, not depending on interface, but directly depending on injecting function and using the function as a variable, as data, is because it's a very powerful technique for functional programming. But the problem with this approach, I mean, not a problem, but every approach has some limitation and some advantage. The limitation with this approach is that, for example, if we want to do something more complicated, we don't have a way to combine stuff together. For example, to do 3 or 4 applications inside a single transaction, we need to rewrite. Another possible problem is that looking at this code, well, it's called load the user, so of course we have a kind of inkling that there will be some function, some impure stuff happening, but there is no way to be sure of it. I mean, that the function that we are passing here will be pure or impure. It will be better, especially in a bigger code base, if we can mark this stuff, that this is the pure part, this is the actual DB, looking DB. And when this is for DB, but of course it's the same thing if we are accessing a file system and stuff like that. So the second approach, so this is one approach which is great. If it works for you, that's perfectly great. A slightly more complicated approach for things when things became more complicated is basically instead of requiring these things here, let's try, for example, with users, just the beginning. What we want, instead of returning a response, we want to return something like a database reader. That's that's why it's called reader. I don't remember how it's called, but it's something database context or database reader. Sorry. And the idea is that, okay, let's create this. And the idea is that inside the database reader, there is a function. Let's call read value that take a, let's say, a database, and return it. So basically, you have this function that take a database and return something. That is, and then you can wrap around this database reader, database context. At some point later, you have the actual database. So what you do, you run your function on the actual database. So, yeah, good suggestion. So basically, you create this function every time you wanted to access database, and then only at the end you run. So basically, here, what will happen is that basically here we go back to the as it was before. So we have a function like load users, and sorry, it's not this one. Is this one? Yes, it's this one. Load user, and that this function wants a database and want the ID and return the user. Sorry. Okay, so yeah. So this is the function that we had before, so completely explicit. And basically here we can say load user and pass in the database. And the database will basically will be here. Sorry. Okay, I needed to fix the return. But basically the idea is that you create a DB reader. The DB reader will get the database, and then you use the database. So, because of we don't have time, blah, 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 let's skip to the actual code. That's just a first second. Yes. And want to show you. And that basically, list user is returning database reader. And the database reader is loading all the users. Yeah, probably here what we want is to not to have a class here, but to have directly the function. But okay, this is I mean, it would be better if it's load users. Actually, since we have a database here, we can also do something like that. Load the users. And then just should be more or less okay. Yeah, something like that. And then basically, because this is a DB reader, we can load here. We have the database, if you remember. Is everybody following me? But so basically, instead of the first solution was first we put the database in an object and then using the function this object. This is kind of the opposite solution. When we don't have anything, when we want to connect the database, we say, okay, let's suppose I had a database. I will know how to get the users. So we, instead of returning, we don't have any parameter, but instead of returning the value, we return the reader of the value. So you ask me, I want a book, and instead of giving the book, I will give you the map where to go to get the book, basically. And the main difference is that user service here doesn't have any parameter, input parameter, so it's not anymore hexagonal port send adapter. But instead of returning response, is returning a DB reader response. The second point that I want to show you when we are using monads is that basically, okay, here we load the data users, and then we wanted to do a user list. I mean, in theory, we can also do like this. We can write stuff like users, and then when the user list the users, and then response body. So this will be page equal response body page. I mean, this will work basically. But you know, one of I mean, nothing wrong with this code, but it's just a bit custom, let's say. So it's a bit hard to reuse this code. So since we have a reader, what we can do is basically transform. So the reader is something that take a database and return a T. We can create a function called transform. Can also be called a map, for example. But I don't like map very much. It's similar to what's happened with the collection when you have a list of integer and you map to a list of string. But because map is already used for the collection, I prefer to use something different. Other language, they use select, I think. C#, I think, use select. Either language have similar things with the different names. But the point is very similar. So you have a generic. You have a function that take a T and return a U. And you return a DB reader of type U. I mean, you take a DB reader T and transform a DB reader. Is this okay? So this kind of transformation is what make reader, if we wanted to be fancy, it's called a functor. And the functor that can be combined together, they are called monads, which is terrible word, but everybody is using, so whatever. But yeah, it's just a very not complicated, but scaling word to say something very simple. It's a generic that can be transformed in another generic. And if you have a two DB reader, they can also be combined. I mean, any interested things, there's the book. It's a bit of a, but this is the decoder concept. So only 10 minutes, so really we need to write. So the third solution, so is using kind of experimental feature of a Kotlin, which is called, I wanted to show you. It's called a context reader. And actually, this is okay for the talk, but don't use in production because it's experimental, and JetBrains already said that it will be different in the future version of Kotlin, and it won't be supported as it is in this slide anymore. But because the new syntax is not available yet, I need to use something. So this is the core. And basically, the idea is that you have a you kind of mark the function that needed to have like a database access, something, with this external context. And when you have the external context, you can use it directly as it was a parameter, input parameter, but it's not in the list of parameter. And the nice thing is that it's transparently pass all the levels. So at the top level, you put a database with this one. You introduce the database scope. And even if HTTP4K doesn't know anything about this, this will be transparently available to list user. And so, I mean, in this specific case, we could have done like this. And you say, yeah, what's the point? Okay, but in a bit more complicated case, you cannot just do a trick like this. I mean, this could be a very complex application and stuff like that. And contexts are easy to pass. One problem that we had with the, almost finished time. Just very quickly, one problem that was with the monad approach is that, we had done a DB reader. Okay, what if I want also something else, like we need a file reader? It's a bit complicated because you need to both a DB and file reader, or a B reader of a file reader. That's very complicated to combine. Instead, with external context, it will be very easy to hear with the DB, with the logger, for example, or something like that. And it will be very easy to pass multiple parameters. The disadvantage of this approach, apart that it doesn't work, I mean, is experimental, they were going to remove, but apart from that, is that you need to mark all your function, which is something that you may want or you don't want to do. I mean, but anyway, very quickly, go back to slides. Well, it's more or less is finished, but thank you. So basically, we can probably take under 5 minutes, but there was 3 different approaches to do the things. Partial application, so you put the parameter first, and then you pass the function with a parameter already included, let's say. Monads, which is you don't need any parameter, but you return something that will be needed to be run at the end against the real. So you don't give the actual result. You give something that needed to be run against the database to get the actual result. But with the transformation, you can do that. And the context parameter that as you said, they, as you saw, they can just put this external marking of stuff that they need, which is very simple, but it also affects a lot of code in the middle because you needed to keep passing this context everywhere. So there is not a silver bullet solution, but there are 3 solutions that you can probably sort out all your problem with one of these 3, depending. The monads, for example, partial application is the simplest way. So if it's good enough for you, I will go for that. Monads allow you to combine stuff together. It's very easy, for example, to handle transaction, database transaction, complicated stuff with monads. And effects, when they will be available, seems to open other kind of possibility, but also to affect your code in the meanwhile. So it will be interesting when they will be available, how people will use them. So the one top is the code that we saw today. So if you wanted to play around, you can work. We actually, but I can assure it works actually, the application start in all 3 solutions. And the 3 solutions are 3 branches, so you can switch. So, okay, this is my, the YouTuber is a talk that I did that is a kind of, let's say, it's kind of related to this talk because it's how to switch from a purely object-oriented to a functional, like the starting point of this talk with the partial application. And also, this is talking about something similar. This is a bit more continuation of that talk. And yeah, that's it. But of course, if there are any question, we have like 2 minutes, so. Okay, one thing that I can tell you is that we are working in a bank with a team in a bank and doing backend with Kotlin, and we are actually using all this technique. I mean, apart from the context receiver that are not ready yet, but so it's not that you needed to use one strategy, but you have a multiple strategy available. But using this approach with the functional programming really helps to make things more testable, easy to be more productive at the end. That's the main point. Yeah.
In Kotlin error handling in functional way, we have error KT. Yeah. Do you have used try? See the LKT. What is your opinion about LKT? Do you know?
LKT.
Yeah, LKT.
Yeah. I use Harrow, and it's great if this is what you want. Basically, it's a very heavy, complicated library. So I want recommend to use if you never use a functional programming. It's like you know. I prefer to do simple things by myself. Have the team. I'm also mentoring teams. Have the team get familiar with the concept, rather than give you a library with 1 million possibility and feature, and like drinking from the fire hose and got. But of course, if you are convinced about functional programming and you want, it's pointless to redo the stuff yourself. Ours is there. You can use. It's not the only way, anyway. We are not using ours, to be honest. But thank you very much for your party. I'll be I'll be around if for a while here in the conference. Any question or stuff?